Welcome to 24 Hours of PaaS, Evolution of the Data Platform. We are excited you could join us today for Steve Hughes' session, Using JSON with SQL Server 2016. This 24 Hours of PaaS event consists of 24 consecutive live webcasts delivered by expert speakers from the PaaS community. The sessions will be recorded and posted online after the event. To access any on-demand sessions, please visit www.24hoursofpaas.com for all session links. My name is Sarah Huang, and I'm the organizer of Saturday Night SQL Virtual Chapter. I have a few introductory slides before I hand over the reins to Steve. Next slide. If you require technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the Zoom button located on the top of the presentation window. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. Next slide. I'd like to take a moment to thank our presenting sponsors, Microsoft, Amazon Web Services, Hortonworks, and Redgate. In addition, I'd also like to thank the supporting sponsors for this event, Hewlett-Packard Enterprise, SQL Sentry, and SanDisk. The staging of 24 Hours of PaaS would not be possible without their generous support, and they are the reason this event is available free of charge. Next slide, please. Make sure you explore everything else PaaS has on offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. Next slide. This session is presented by Steve Hughes. Steve is a principal consultant at Pragmatic Works. His area of expertise is in data and business intelligence architecture on the Microsoft SQL Server platform. He was also the data architect for a software as a service company which delivered a transportation management solution for fleets across the United States. Steve has co-authored 3 books and delivered multiple presentations on SQL Server and data architecture over the past 6 years. Now I hand over the reins to Steve.
All right, thank you very much, Sarah. As we get ready to start this up, my slides are progressing a little slow. I'm not sure what's going on. There we go. So we're going to be talking about JSON with SQL Server 2016 and its use cases. A couple of notes I will show at near the end as well, but if you want to get all the code and any other comments I have on this, you can find it on my blog at dataonwheels.com, and just look for the category JSON and you'll be able to track all of that down. All right, so let's kick this off here. So a little bit of history before we get into the cool stuff. on SQL 2016, and I bring this up because when I early on in my career, I explored the XML data type work quite a bit. I actually had a couple presentations at Summit on it, and it was really cool to look at what they could do. And if you've not used it, I encourage you to at least look at it as well, because JSON and XML kind of have the same underpinnings and same thing just trying to accomplish. They're giving us well thought out data typing and just like, hey, look at all this cool stuff, you can encapsulate it. Web designers loved both of them. Now they love JSON more than XML, which is why we're talking about that next. But these are some of the support that you could see in SQL Server 2008 and moving forward. The XML data type was actually a data type. There was methods that supported that data type explicitly. XML schemas could also be supported in SQL Server, can still be supported there. XQuery is, the XQuery components of .NET Framework were actually embedded as part of the tool. OpenXML, 4XML, and OpenROSA were also supported. The reason I want to bring this up now is as we dig into what JSON's doing, I want you, one of the key things I was looking at when I looked at JSON in 2016 was where did it differentiate itself from XML and how was it used? So as we dig into this, my understanding would be that most of you are probably not JSON experts in the field, so we're going to do a little bit of coverage around that and compare it to XML and then dig into how it's different and what does work and does not work as expected in SQL 2016. So first of all, like I said, they both have the same overall purpose. The goal when you read either one of those is the key that I just said. You should be able to read them. They're self-describing portable data. This is the data that, in particular has come into play more and more off mobile and web. XML is more verbose than JSON. This is the key area where developers continually tell me that I'm wrong. They like JSON better. So the reality of the situation is the more bits that are involved in the container of data that you're going to do, it hurts performance, especially in a mobile world. As data is transported back and forth, you want to keep this, concise as possible. The more complex the data, the bigger the impact XML has on the verbosity that you see. The other reason developers really like JSON, it has a very flexible design. There is no concepts like schemas involved in JSON. It's pretty much document databases are built around it. You can pretty much add and take things away. There's not a whole lot in JSON that's structured from that perspective. You can, developers love it because they don't have to wait for DBAs to go out and fix the database and so on. Now, to look at the examples between JSON and XML, this is essentially the same file. Now, this is a small example, and really, in some ways, it's kind of difficult to see how the data is that different. But you notice in XML that we have tags, and those tags are very verbose. And we have closing tags, opening tags, and so on. You can also see that we have the seat array on JSON, and we have a subset of seats in XML as well. So in all these cases, really there's not a whole huge difference. The syntax is different, but as the data gets larger and larger, JSON is actually more simple and doesn't have as much verbosity around it. XML really has a lot of rich pieces you can add to it. JSON, it's basically objects and arrays, and you work from there. In the JSON example, which we'll focus on now, you'll see that an object is in curly braces and an array is in square brackets. Everything else is attributes. There's no data typing or anything like that on either one of these. So when we look at what SQL Server 2016 has to offer around JSON support, a lot of us were very excited when this came and they announced they were going to support JSON. So what they do have in there right now is the JSON functions. We will show demos of everything, and you will see these examples. But JSON has the basic functions to query JSON data. So you can either generate JSON, you can ingest JSON, you can actually interrogate JSON as well. And that's what those functions are about. It's really important to understand that was kind of the goal. One of the key differentiators between JSON and XML is that JSON is not a data type. Data is stored in varchar or nvarchar type fields, and as a result, native indexing is not supported. I'll talk about more at the end. What I really want to point out is because of this, the support for JSON is not nearly as robust as the support for XML. So a little bit more about those JSON objects we're going to be looking at here in the next hour or so. We enclose objects in curly braces or whatever you prefer to call those. The most common format for objects is a key-value pair, and that's what really is the core of this. So when you look at document databases, like DocumentDB in Azure or Mongo, they tend to use JSON because of this key-value pair concept. Objects can be nested, so you can get a key and then you can actually add more key-value pairs within it, as you can see in that example. JSON arrays. This is a very important structure within JSON. We'll be using it a lot when we interrogate some structures. But square brackets enclose those arrays. So you can see a key and then you can enclose them. The assumption is everything within that array are the same. There doesn't have to be, but that is the assumption that most people assume. So here's a simple example of JSON. And I have the exterior object as restaurant, and then within it are objects contained within the object. So it's nested objects. So the restaurant ID is actually another key value pair object within the context of the restaurant. Restaurant name, the same thing. And then seats is an array with the seat number object and a key value pair as a separate object within it. So the array contains multiple objects that are similar in type. Now we get into some cool stuff. So as we start to delve into what SQL Server is supporting, it did bring in some of the same concepts as we had with XML data type support. So $sign will equal the context. Where are we at? If we say $sign with an object or an array, we're going to get that immediate one, and we'll show examples of all these with the functions. Next thing is we have a $sign with an object array or an object. So this really works if I'm looking for nested objects or an array with an object within an array. You can nest these really, really deeply, but only one array can be referenced in OPENJSON, and that's going to be really important. As you dig in, you can only get to the one level. As we start, we're using JSON path with OPENJSON as well. We have the ability to either go, use lax or strict. Lax lets us actually return null for missing attributes, so we have a great example of that, but strict raises an error when that happens. This gets into a scenario, and where developers have the ability to change the attributes contained within objects or arrays. So they can look differently from time to time. Let's take an example that on my car. When I originally built my car object, I had within it a attribute that was in a key value pair that actually had the color of the car. But now I've got a new one that actually says that I want to know are the windows tinted. Well, all my previous objects that I had stored don't have that information. If I return lax, when I actually call out a function and call it out of the path, what will happen is I will actually get the data back, and it's fine. It'll go, hey, here's null value for what's there. We're not going to try to match it. And this is really important to understand in a SQL world, because what we want to do is we want to make sure that we understand the data we're pulling out, and this is one of the hard parts about JSON. Now, if we do strict, we can drive the developers nuts, which sometimes that might be our goal as DBAs and folks who actually work data and expect structure. Strict actually will say if I am missing an attribute, raise an error, which means that the application will have to handle the error. I would say in most cases, typically we will never use strict just because it does raise an error and defeats the entire purpose of JSON. But if we need it for what we're doing in some of our internal querying, we would have to still handle the error using try-catch or something similar. Then finally, you can see we have the object array combination. This returns an object from array. It is zero-based, and this is very similar to what we had to deal with XML. If I'm trying to dig out something out of an array, I have to know what position it is within the content. Typically speaking, that's not something that's very easy to do, nor is it very intuitive for us, because if there's 14 objects or 100 objects in the array, how do we know which one we're looking for and what we want to find? And you'll see that that's a complication with both JSON and XML that we have to deal with. So the next few sections we're going to go back and forth between the slide deck and demos. In this scenario, we're going to talk about OPENJSON. So OPENJSON takes and converts JSON to tabular format. This is really helpful when we go to ingest data that's coming to us in a JSON format. If you have a store procedure picking up content coming in from from a IoT scenario where that's the data type that we're getting. You can bring that in your store procedure, but what's really cool is you actually can convert it to OpenJSON and then use those values. You can actually define the schema that's coming through, and you can use explicit schema. We'll show you that with the with operator. But one of the more significant features is that we can use cross-apply and join our JSON data with relational data, or join it to a cell so we can actually flatten out the arrays. Why these are important is that we actually want to make sure that using OpenJSON we get the data in a format that we can consume, and that's what we are going to look at now. So I have a number of OpenJSON examples, 5 I believe to be exact. We'll start from the basics. So let me switch screens here. Look at that. That worked better than I thought it would. All right, so the first one that we are going to tackle is my restaurant SQL. The example I have is a restaurant with seats. It's pretty basic from that perspective, but let's run through this code. The results here. All right. So as you can see here, we're starting with the basics. I'm actually creating an nvarchar max variable, which will contain the JSON data I'm working with. So here we can see that I have my JSON object. This is very similar to what we saw in the slide that we were using. I have a restaurant object, and then within it I have a number of key value pairs, which are actually objects as well, or attributes about the object. And then I have this location, which is another nested object within there, so I can say, hey, I have this location, here's the attributes I have, and my restaurant code. So what's interesting about this, when I use standard OpenJSON, which you see here, I'm going to basically pull the variable, or if I'm actually pointing at a database, I can point to a field. And I am going to pull in, if you remember our path statement, I'm going to pull in the root path, which is where I'm starting at restaurant. It's the root, and then restaurant, and go, hey, go grab me the restaurant data. So let's look at that. And actually we'll look at the other one as well. This one here will actually give us the data out of the nested location. So you can see it's truly a path that we're following. Each dot represents a little bit deeper in the path we're looking. So this is all object-based at this point. So execute this. You can see here, you get key, value, and the type. And I did not ask for any of that. So in OpenJSON, it basically took that value, and we really, this is not the result you were probably expecting. What it's giving us is saying, hey, for each key, here's the value I have, and the type of data that's there. So the typing is numeric in this sense, and you can see that 2 is a numeric. Keeping in mind these are more along the lines of .NET data types, not SQL data types. So we have a string, and then we have a string, and then integers, and we also have the location here, which is still embedded as a string, but it's noted that it is an object type here for JSON. Now when we go and dig into this, so as we dug into the path, we went from restaurant to location and give me this information. That's what you see here. We get the key, the value, and the type. And as I pointed out, this is one of those things, this is the most basic version of OpenJSON that you get, and it comes out in the default schema support. The default schema will always be key, value, and type, and you'll see the data spread out this way. The next example, we're actually going to look at an explicit schema. So let me close this guy. And we're going to go for a seat array. So this is a little different. We're actually looking at a list of seats, and you can see here that we're pulling out an explicit schema. I'll walk you through that as well. So we have this object now. I have my seats array, and I have an array of seats as we expected, which also have the same type of key value pair. Now I'm going to actually do select from my OpenJSON, and you can see here I'm doing a case statement against the data, but the with statement here is the most important part. The with statement says, hey, I know I have this thing called a seat number, and it's an int, and here's where I'm going to find it. And so each one of these is I'm going to give it a field name, a type, and where it can be found in the path. So now I can actually see that I'm going to open this up in seats, so I'm going to be able to pull those out. I'm going to get this set up the way I want it, which I want to see this in a table format or a tabular format that I expect to see, which is these as column names. So let's go ahead and execute this. And you can see here now I get my seat number, so just as I specified, my seat code, my table number, and the table type. Now you notice that table number is null on value 3. This is because we're using lax. And lax is the default, so I don't actually have to specify in here that these are, I'm looking at this from a lax perspective. We'll show you what strict looks like here in a second. But in the third record, I do not actually have a table number. So if you look here, I don't have to use all the data that's in there, but I also don't have a table number, something that exists in all the rest of them. Now I have the same type of fields, but here I actually have a restaurant ID, which I'm not using in my results, and nothing broke. This is normal for JSON. So what would happen, typically speaking, in the application, when they were to open this JSON segment back up, any of these anomalies would be corrected to the latest version if that's how it's been coded. So then it will clean this up at a later time. But for us as database folks, who actually, in particular, when we think about reporting and some of the other things we're required to do with this data, if this were added after the fact and we weren't told about it, there's a good chance we would never account for it in our in our schema, and then we would actually not have that data, and someone would tell us, hey, why are we missing this new data we put in? And we'd go through the process and say, you didn't tell us it was there, and welcome to the wonderful new world of working with data that can be schema defined however a developer likes it. Go ahead and imagine with me, you will, a misspelling in one of these because there was a bug in a piece of the app, and you can imagine what kind of havoc that will cause as well. So that gives you some of the, that gives you an idea of how to use OpenJSON to actually put this in this tabular format. Now the next one we'll show you is actually using strict, and let's go grab it. So the reason I want to show this is because here the difference in the code is right here in this statement. So what we do on this example is I'm actually saying, hey, I want that table number. It can't not exist. That's a good double negative. Because I need to have the table number for whatever reason in order to do my work. If it's not there, raise an error. Now, reporting or whatever else we would do, we would have to actually handle that error. This is why I don't believe that we will use this very much except for extreme cases where it's needed. It's also why it's not the default. So if we go ahead and execute this, let's see here. We actually get an error message. Zoom in a little bit. Oh, wrong one. And you can see here, maybe, if I can get that zoom to go the right way, I don't think it's going to go where I want it. Let me go ahead and get out of that mode because I'm in double screen. Basically, you can see we actually have property cannot be found on the specific JSON path. Because it's not there, it raises an error blocking this from actually happening. It's important to know it's available. I do believe that given the nature of JSON, it is actually great for database folks and bad for developers, meaning that we like to know what's in our data, and developers like to change what's in their data depending on how they feel the app should work at any given time. So that gives you a very clear example of how to use strict and when it will actually be an issue. The next piece I want to highlight is using cross-apply. So I'm going to use this open restaurants. I think this is the right one first. Yeah. So this one here. Let's look at the XML. Or I'm sorry, the JSON. Talk about the wrong thing too much here. And you can see right here we have what we had in our restaurant object. So this gives us the key value pairs around our object, and then we have a seed array. And this is a typical pattern that would be followed. So I have an array of objects that are part of this here. If you think about it in a transactional world, I might have a ticket information, all order line items, whatever makes sense coming off your system. But this gives you a good example of this array. So when we come down here, we're actually going to use OpenJSON to get the restaurant. We're going to pull the restaurant name using our explicit schema. And then we're going to cross-join that with the seats, and we're going to go pull the seat numbers and table type. So it's going to go through and actually cross-join that. Now this works because I have one restaurant and multiple seats. It doesn't work. It doesn't work if you don't have a model like this. So this is kind of a limited use case. But I want to go and show you how you can do this in scenarios where, in particular, if like the JSON object is self-contained and it looks similar to this structure. So if we execute, you can see now what it did is it took my first results and copied them multiple times and then cross-joined them here. Where this breaks down is if I had two restaurants in here, this would actually cross-join the entire set, and we would not have the ability to make this work as we expected. Now, on the other hand, if we go over to the restaurant, we actually can do the same thing if we're joining to our restaurant table. So I am using a couple tables for this example, including DBO restaurant, and that's what we're looking at here. And we're going to go join the seats that are coming out of the seats JSON record here. So if you look, let me show you the table so you can actually see what we got. Let's go ahead and select the rows here. So this gives you the table structure that we're working with, so you can see clearly what we're doing and how the cross join will work. So right now you can see this is what I'm storing, and all my seats are stored in JSON. Now this is very similar to what you'd expect. It's stored in an varchar field, and it has my seat array in there, so I know how many seats belong to the restaurant that I'm looking at. So after I go back to my OpenJSON, I am actually cross-joining the restaurant seats. Now this works, I want to be really clear, this works because each restaurant has the seats JSON field in it, and I can now do OpenJSON and open this up. So what I've done is I left the original, I did not take anything out of the seats table, so you can see the whole thing. All right. So we execute this, as you can see, I guess it's already the same thing. I actually am pulling seats JSON from the restaurant table, and then I'm actually splitting out. Now this seats reference is actually this reference here, so it's the alias for the JSON file that's embedded in that. And this is a pretty common use case that you would see. You can actually break this out. Now the question has been raised multiple times for me on scale. I'm not entirely convinced this will scale as expected because it's doing a conversion at the end. But it will, for simple results or for reporting, it will get you what you need. And that is OpenJSON. So let's go back and kick this off again. For JSON, so the OpenJSON actually lets us interrogate a JSON record, a JSON file, whereas for JSON lets us generate one. In some ways, this is what it's often equally important to be able to generate JSON to be consumed by the applications as it is to be able to consume that data or ingest that data as well. So as we start working through this, basically it returns as JSON sets, and I'll show you a cool trick with Visual Studio Code to help you read that. But our output options are for JSON auto. It just sets the formats as arrays and nested arrays when joins are used. It aliases our object names. You want to use aliases because it makes it meaningful. If you don't alias properly, this gets really weird. It doesn't help you much. For JSON path allows you to specify the path for complex results. We'll show you an example of that. You can actually lay out what you want, similar to the explicit schema work we're doing in OpenSQL. I'm sorry, OpenJSON. And then root allows you to add a root level, because this would happen if, for instance, well, when you'll see, you can actually, like the seats we have, we could actually generate an array of seats without giving it a root, and so there's no root object containing the array. It looks kind of odd. So this helps format, adds a formatting technique to the results that we're looking at. All right, so for JSON. So for JSON auto, it's going to, we're going to just go ahead and let this run out, and if you're familiar with using XML, you get the results the same way. It gives you this nice little link. You notice it's going to show this to me in an XML editor. It is not XML, so it does 0 formatting, so you have no idea if you got it right. So we're going to select all of this, and we're going to go to Visual Studio Code, and we're going to get rid of what's there, and we're going to paste this in. So why Visual Studio Code? I found this tool. I love this tool. It's really a lightweight coding tool, but most importantly, I've copied in JSON, and the key here is I have a JSON file with .json extension that I've created. I now can right-click in here and say format the code, and I can see the results. It'll format for me. This is so nice. I can see everything in the format. I can double-check that the results I'm returning from my for JSON statement are correct. So in this case, if we compare notes with what we did, go back to here for a moment, we basically selecting the restaurant information. So go back and let's check the JSON file that we generated, and you can see here we have basically 2 restaurants that are in an array, and we got the results we totally expected. All right. So let's minimize that. Let's go to the next one. So the next one, we're actually going to create arrays with some nesting. As you can see here, we have seats and seat number. And here's where I said the alias matters. You're going to see that without this here, it actually gives us a meaningful name to the array. And we're going to give it a root value of restaurant, so it's a more complete JSON document. So let's go ahead and execute this. Go out here, we're going to do the same thing. Go here, format this code. And now you can see that I have a restaurant object at my root level. So that's a root that we put in there. And each restaurant that we created is now here. So I got the Minneapolis restaurant. And I have seat number, table number throughout. And I'm using different values. As we scroll down here, we got to get to, there's a lot of seats in this restaurant. Still going. Oh, most people only picked one restaurant. So this gives us one restaurant with a seat number on there. The alias piece I was telling you about has to do with this right here. Without the alias seats, which we had put in here, that alias allows us to actually get a meaningful name to the array. So now you can see how the array is built, and this is a great example, another great example of how you can get data out in 4JSON format. All right. We have one more to show you. So this is still using auto. So let's look at path. Now this is probably my preferred method. It actually gives me the results I like the best, and it's the easiest to work with. But path lets us use the dot format, and we can actually go through here and you can embed the array in this format as well. But the results don't group in arrays as it does for the for auto scenario, and I will show you what I mean. This is not quite as clean. You have to be very explicit and work with the syntax on this one quite a bit. Let's go and format this. Oh, it's just going the wrong spot. There we go. So you can see here that it actually created individual objects for each table. So instead of creating an array, it created a bunch of nested objects. So depending on what the data you want to push out, this may be the path you want, or you may need to work with the syntax a little bit more to get it in a format that is more appealing for what you're trying to accomplish. But that gives you the idea of, so if you go back and look at our 4JSON statement, we said path, we specify the path, restaurant.name, restaurant.city, restaurant.seat number. So that embedded it, and we would have to actually create an array in here as well, and it doesn't group it as nicely or as intuitively as the example we had before, which in this scenario, it honored the join and created a nested array based on what it thought automatically should happen. So by doing this, it actually said, okay, you want to do this the seat number, we'd have to work through the path statement to get this to a different format than what we're expecting. But that gives you the 4JSON format and a little bit of how to play with it, and a little introduction to Visual Studio Code as a tool that you can use to actually look at the format of your JSON. All right, back to the slides. JSON functions. There are 4 functions for JSON. These functions are used like you would use in any other type of functions within SQL Server. You will be using the path that we talked about earlier in order to format or format your request or do requests as you expect. So the functions are pretty straightforward. I have them on the screen with their definition. So is JSON does exactly what you expect it to. Is this formatted properly as JSON? So are all the curly braces and square brackets where they're expected to be. This is really important if you're actually consuming JSON as a type coming in from like into a store procedure parameter, and it's going to come in as a varchar, and you don't know for sure if it's formatted correctly. This will let you test the format. If you're planning to store it as JSON and you want to actually test it before you store it, when I say that, you're going to put it in a column that you know should be formatted correctly for JSON. You can test it at that point as well. So this just is a great way to make sure that the text values or the varchar values that you're looking at will actually be JSON, because if they're not, then you're not able to use some of the other functions we have available. JSON value will go grab a scalar value out of the JSON document. So you can actually pull an attribute, you can pull the attribute off an array, an object within an array, but it's basically focused on a scalar, so it's always going to return one value. As a result, when we look at it and you go interrogate arrays, you actually have to specify which member in the array based on that zero position that you're looking for. JSON query will actually return JSON formatted array or an object, so it's basically going and grabbing a subset. Now that's helpful if you're actually can pull a subset of data, or you want to grab the array and then you want to do something with the array when you get it, like actually use OPENJSON to turn it into a table. This lets you grab the piece of JSON that you want and work from there. Finally, you can use JSON modify to modify JSON properties. I am not, this is similar to what we could do with XML, and I have a demo for it, but I typically don't see us as database professionals doing a lot of modification of these documents, because at the end of the day, I'm not sure that that helps us at all, because it's, realistically we want to get this into a different format so we can work with them in a much cleaner way. All right, switch back over to our demos. So in this case, we're going to go through each of the functions. You can see here, I think I already showed you this. This is my table I'm working with, and I got this table with the seats JSON file column. This is a typical format, so we'll look at this for a lot of the interrogation we're doing. So the first thing we're going to do is we want to make sure if the format's correct, and it returns a 1 if it's correct and a 0 if it's not. So you can see here that I'm in my 2 restaurant records, I have my seats are formatted correctly, and so I'm safe to move forward on there. I had to do this as an example because I got some good XML that I wanted to use and see if we could pass that in as JSON and it will turn a 0. So now I know that my XML data will not pass the JSON test. Not that it should have surprised us, but at least it lets you know in a situation where you may have had an application that's been modified to move from XML to JSON that it will not be compatible and you're good to go there. So looking at some of the scalar value options, now this is where we start looking at the path, right? So in this case, I'm pulling out my restaurant. I'm looking at my field again. This is the field I have called seats JSON. From the root, I am moving into the seats array, and I'm going to pull element 0 as the first seat in my array. This is all being done for my restaurant table. Now this is one of those areas where I mentioned that, hey, if you have multiple members in your array, how will you know which one you want to go after? You actually don't. So as you build out this and you work with arrays, you'll find working with arrays can be difficult because you're not for sure which element you want to go after, and you have to figure out how you would go after it. And there's not really a clean way to go interrogate the array, say, hey, I want, I need seat 4 in the array, which is actually I need 3 now because it's 0 base. We all have fun with that. And I think, all right, so then I go grab the value. I really can't do that. So when I'm working with scalar value, its advantage, its best advantage is using off a key value pair, and this will actually point to the key, and we can get the value out of it. But when it comes to finding the right element in the array, there's no guarantee that we'll get the correct position within our array. JSON query always returns a snippet of JSON. So in this case, if you look here, we are going to be doing the same thing. We're going to pull the seats array out of here as a JSON snippet. So let's go ahead and do this. And you can see that it pulled the seat codes, and just it's pretty straightforward. It just went after seats and returned those values as is. Now, you might say, well, what's really different? What's really different is that it actually stripped the root out, and that's pretty much the extent of it. If we add elements to this, actually this should be seat code, I think. And then let's run that again. Yeah, because it doesn't know which one I'm picking up, so I'd actually have to specify the array that I'm looking for. So this gets into that, the scenario where you're like, okay, how do I find the pieces I want? And you'll see right away that in order to pull out the next level of attribute, we actually have to go and dig into it. So, all right. Oh, you can see I demoed this before RC0, and we are now in RC3, so this does work now. Let's walk through this real quick so you can see how I use modify. I'm basically using a variable to do this as well. So I'm creating my REST JSON variable, and then I'm going to go in there and modify based on the path again. I'm going to switch my zip code to a different zip code. So I'm just going to print the results out. So right now you can see what I'm pushing in is zip 55450. When it comes out, it should be 55337. And that's exactly what we have here. So we now have the correct zip code at 55337. And that's the expected results in the modify. So that's a quick run through of all the functions. It's a pretty short list actually. And you know, I just wanted you to see all of them in action. So the most valuable one really, you know, these two here are very valuable with value and query, as long as you stay within the confines of objects. Once you start messing with arrays, that's when you start to see difficulty dealing with both of those, because the path requires you to go discover which position in the array you're looking for. All right. Indexing JSON. So this is a problem child, shall we say. Because JSON is not a native SQL type, it has no equivalent to XML data type indexing. This is a problem at scale. One of the advantages of XML was the XML data type could support indexing. And as ugly as you might have thought that to be, and as painful it was to set up and get it working necessarily the right way, it was an option if you used XML extensively within your environment. You were able to use the ability to actually apply a schema, to then apply indexes and apply an XML index, which stripped it all out and did some work. But if you had to use a lot of XML and you use a lot of XML documents in your data and needed them for reporting and so on, this allowed you to actually index it. So the recommendation, the only one that I found so far, was to use computed columns on the table with JSON value functions to create the indexes. Now, the problem with this is that, as you saw, arrays cannot be indexed as a result. Because realistically, you can only pull a scalar value, throw it into a computed column, and then index that computed column. So SQL Server knows how to look for that, but at the same time, it's really has limited use as from an indexing standpoint, and even more limited at a scale standpoint. I mean, you're using computed columns to get what you need, but I'm not a big fan of this approach. I would have rather seen them actually take time and put JSON into a data type and have it be able to be indexed properly. So that's probably the biggest flaw I see in this. I have a blog post called JSON, the good, the bad, and the ugly. This gets into my ugly portion, because at the end of the day, it's not a very effective indexing model, and will take a considerable amount of time to get where you want it. And if you're using arrays and you want to index the arrays, it's pretty much impossible to do so. So as you can see, this is where the JSON, we kind of wrap up here. The JSON support within SQL 2016 has advantages, especially if you're using it for reporting workloads. You're going to find that some of these functions are going to be really helpful when you have to report on data that's stuffed into these JSON types. The ability to actually go after it and pull some of those values out, especially using cross-supply in an OPENJSON format to reference the other data to get you some of the context around it, will actually help quite a bit in the common reporting workload. Also, if you're bringing in data from IoT and mobile apps where it is already JSON formatted, this is also can also be a very positive thing to use these, because you'll be able to interrogate them, you can check the type, you can actually generate JSON formatted data out of your databases. But this gives you kind of that high-level view of where JSON is at. And I know that for me, I had a certain level of disappointment. Now, I was hoping for a little more extensive support for JSON, given the fact of how popular it is out there. But this is definitely a great step one, and an opportunity to take advantage of some of these functions in a case-by-case basis. As I noted before, one of the biggest concerns raised to me, and a couple of times I've talked about JSON, is directly related to performance at scale. There is nothing without the indexing capability, performing some of these functionality at scale, it likely will be problematic. So you'll have to, your mileage will vary based on what you're seeing. And that is a wrap for me. So usually I take more questions during, so we're going to see if anybody has any questions right now.
Just a second, let me see. Okay, this person says, so JSON auto converts relational data into JSON format, correct?
Yes. I have to go back. Let me go look at the example. Let's go ahead and have a look at that example again. I can reopen that. For JSON, there we go. Yeah, so like for JSON Auto, this is the first one we ran. It does a fairly simple, straightforward format. So that's probably the simplest format you can do. This is using using the auto version. So for JSON Auto. So for XML Auto did something very similar. But this, at least gives you that idea that you can dump this data out pretty quickly into a JSON format to be used by your other applications. So yes.
So the next question, so JSON file size would be limited by the wildcard or n-wildcard max size.
That is correct. So the largest it can be is 2 gig.
Okay. When huge number of JSON has to be stored from the application to the SQL server, is it a good idea to have document DB as the storage for JSON?
So that's a really good question. I'm going to go with a great consulting answer that it depends. If I were storing that data, I know I had to use it for a lot of other purposes besides just storing it for JSON for the application, I would still try to get it into a SQL Server database. As you recall, the restaurant table that I worked with, this one here, actually had a blended data. So I had JSON data. So as data's coming in, if it has a surrounding key attribute or a root value that you can turn into fields and store the underlying JSON data or strip it onto other things like this, you actually are going to be more flexible in your solution. If you have very large JSON, which always concerns me, I did XML work and we ran into that same limit, the 2 gig, and that typically meant that something was wrong with the source because it shouldn't, it's hard for any system to consume that data that size. Ideally, you're breaking JSON down into chunks that are consumable by a SQL Server. If you're 100% JSON environment, then DocumentDB could be a better choice. At that point, you have to consider what your reporting options will be going against that data source.
Okay. For reporting against JSON, would you typically extract the JSON to a table with columns for each element and then report against that, or leave it as JSON?
It depends on how much JSON and if it can be easily done. Because of the nature of JSON is that it can change based on what the developers are doing, a lot of that flexibility goes away once we stick it into tables, and we'd have to actually match it correctly. The flip side of that is in order for us to actually report on it effectively and do it in volume and have the performance, it needs to be flattened into tables as much as possible. So like in my scenario where we're looking at using cross-supply to bring this data out and do seats per restaurant, that's a great operation and will probably scale fairly well for, if the JSON is fairly straightforward and the record's built correctly. But if you have all JSON data, it will always be an issue because, like I said, one of the reasons developers love JSON is it's flexible. One of the reasons we hate JSON is because it's flexible. So we're dealing with competing interests at all times. Power BI has a JSON consumer that can help potentially make this easier on you from a reporting standpoint, so it's something you might want to look at for that as well.
Cool. JSON in SQL Server 2016, is it the same MongoDB for big data app?
No, it is. This is purely T-SQL add-in additions. Sorry, T-SQL additions to support JSON formatting and some of the core JSON functionality when it comes to relational intermingling of relational data.
Okay. What is the limit of JSON data in SQL Server? The string data type?
You can only use varchar and varchar max, and both of those I think top out at 2 gig on their storage. So if you end up using varchar, it's essentially about a 1 gig file size, or from a character standpoint. But yeah, that limitation is limited by the field size. It's not an unlimited field size.
Okay. For text, does it keep the original formatting?
To keep the original formatting. When you store it in there, it will. Oh, you mean like if it's got all the white space formatting? Actually getting rid of that will make it more efficient for storage. The formatting that we're showing in Visual Code is actually looking at the braces and artificially applying that. So when you saw the data that we were pushing here, it comes out totally flat, as you're seeing here. So no, it doesn't. The formatting, actually you don't want it to keep the formatting because the white space, if it actually kept tabs and spaces, it wouldn't be a good thing. It actually makes it more, take up more space.
Makes sense. How escaping for special characters work?
That is a JSON function, and I don't have that information in front of me, so however JSON supports a special character, it would be supported as long as it's supported in text within SQL Server. Shouldn't be a problem. There's no limitation on the text we can support.
Okay. For large JSON docs, does SQL parse the whole thing first before starting to process?
Yes. So that is one of the areas of when we talk about scalability issues, is the fact that it is actually going through the entire document and all the fields. So if you have lots of large documents, the performance in this will not likely be very good at all. So indexing was designed to help with that, so it would only parse those ones that you wanted. However, that also is an issue because of what we already talked about, because it's not a native data type. Indexing is not easily handled.
Okay. SQL 2016 had some new string functions like string split, string escape. Does these work on JSON data as well?
Yeah, because JSON data is realistically just strings. So it works because it's not a full data type, you can take advantage of all those type of expressions.
Any function in JSON to check if the string is indeed a valid JSON format?
Yeah, the isJSON function will cover that. So if you bring it over into a variable or a field, you can actually just wrap it in isJSON and it'll test it for you.
All right. I think that's all the questions we got.
All right. Thanks, everybody. Like I said, you can find the code out on my blog site, dataonwheels.com, and just search for, look at the JSON category. You'll find a couple blog posts, including a presentation similar to this one, which has all the source code. So,
cool.
Let's get back to the slideshow here.
Yeah. Okay. Yeah, make sure to stay tuned for our next session, relational databases versus non-relational databases versus Hadoop with James Serra. And thank you all for attending. Thank you, Steve.
Thank you, everyone, for coming. Enjoy the rest of 24 hours of PASS.
Thank you.